Welcome to another episode of the 8-Bit Guy. Today we're going to be talking about BASIC, the computer language of the 1980s. Well, BASIC was technically invented in 1964 by John Kemeny and Thomas Kurtz of Dartmouth College. These computers were not at all what you would think of as personal computers. It really wasn't until Bill Gates and Paul Allen, who worked at a little startup software company known as Microsoft, brought BASIC to some of the home computers of the 1970s, that it really started to take off, and in the 1980s saw an explosion. When you look at all of these computers here, they're totally different from each other in hardware, software, and even the user interface, but they all had one thing in common: they ran BASIC.
BASIC was the great equalizer of the home computer revolution. Early personal computers were not intercompatible. You couldn't take a binary program from an Apple II and go run it on a PC or a Commodore 64 or an Atari 8-bit system or a TI-99 4A. They were all different, except when it came to BASIC. BASIC was taught in elementary how to use your home computer books. It was taught in schools. And because BASIC was the same language across all of the systems, you could take what you learned on one system and use that on another system.
One of my favorite shows, Futurama, often has little hidden gags about it, such as Bender's internal CPU is a 6502, the same CPU used in many home computers of the 1980s, and you can see basic line numbering schemes on everything from his Home Sweet Home poster to the founding principle of the Church of Robotology, where instructions are clear that if you sin, then move to line 20, which says you will go to hell. Also, Kif creates his HoloShed programs in BASIC.
4 million lines of BASIC.
So, I'm not going to teach you how to code in BASIC in this episode, as that would be pretty boring. But I do want to point out, for example, how this code is recognizable as BASIC code. That's because it uses line numbers separated by tens. In BASIC, you start every line of code with a line number. And we were always taught to start with 10 and then go to 20 and then so on. And the reason for this is that computers didn't really have any sort of text editor or word processors built in. And while generally you could go back and edit a line to add something, often you might need to insert something between two lines. So by leaving space, you could type a line 15, for example, and it would insert that into the code. Okay, so I want to show you this book, 101 Basic Computer Games. This came out in 1978, at the very beginning of the personal computer revolution. Now, the book is historically significant because it is the first computer book to sell over 1 million copies.
Well, my first exposure to BASIC at all was as a kid. I was around 7 or 8 years old, and the local library, they had a technology section for kids and the children's books section, and I saw this book in particular, Basic Computer Games Microcomputer Edition, 101 great games to play on your home computer from Creative Computing. This was released in October of 1978, and they had a bunch of copies of these still just lying around in the library in the early 90s, and so I took it home, and it had all of these really cool looking games in here, and yeah, it's just all type-in stuff. And all these commands, I just put them in my Packard Bell MS-DOS computer, and not a single one of them worked. But of course, that is because, now I know, that computer obviously was a DOS computer. It didn't have Microsoft BASIC running in DOS.
So I just recently picked up this book, and I was looking through it, and I discovered that most of the games in here were targeted at the TRS-80 or the Commodore PET or the Apple II or some of the early CP/M machines that could run BASIC, like the Altair. So I decided to try typing in one of these games, just see how long it would take. I looked through the book and I decided on Hangman. It was actually one of the shorter games to type in. I used my Apple II since it is one of the target machines. I set a timer so that I could see how long this would take me. And so I went to town typing this thing in. I remember doing this as a kid and it took forever. I thought maybe I could do it faster as an adult. However, this stuff isn't like typing spoken words. There are lots of symbols and numbers and stuff, so it actually takes longer than you would think. Time just kept dragging on. At last, I was finally done, and the timer says, holy cow, 47 minutes. Let's list the program so we can see how much I actually typed. Well, let's try it out. Looks like they were expecting an 80-column display. Anyway, let's see if it works. Let's try E. Hey, I got a letter. I noticed that it redraws the entire screen layout each time, and that's because BASIC doesn't have any standardized commands for moving the cursor around on the screen, so these games had to be treated like they were working on an old teletype. Ah yes, a syntax error. I would have actually been surprised if I managed to type all of that without any errors. So let's examine line 520 and see what the problem is. Ah, I see what I did. Let me retype that line. Okay, so the game seemed to be working now.
So one of the things that I noticed about this book is that none of the games in this book have any graphics. They're all text-based games. Now, that seems rather boring in, the 21st century, but in 1978, that really wasn't much of a problem considering most computers back then didn't have graphics anyway. And even when computers like the Apple II did show up on the market that had graphics capabilities, the commands were proprietary to that specific machine. So you still couldn't publish a book that would have basic listings for a variety of different computers without being text-based games. So none of the games in the book are likely to be considered fun in the 21st century, but I think what this book represents is more a historical picture of what the software situation was like back in the late 1970s. I mean, you couldn't just walk into a Kmart or Target and buy a game for your computer right off the shelf. That didn't really happen until the early 1980s. So when computer manufacturers came out with their computers during the late 70s, they really anticipated that most users would be writing their own programs in BASIC, or they would be typing them in from a book or magazine. And BASIC was well suited for that task.
So yeah, the big thing back in the day was you would get a computer magazine and it would have maybe 2 to 3 programs in it that you could type in. So there'd be like 10 pages of listings of either BASIC or sometimes machine language. And you would just sit there and go, tip, 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 type it all in. And it was kind of fun because at the end, you would have a sweet game. I mean, paper was cheaper than discs back then. Oh, how times have changed.
So I remember waiting every month for the magazine to come. It would arrive. I would read it cover to cover. And then the next day I would take it to my school's computer lab, which had roughly 10 Apple II systems in it. And I would key in the BASIC programs.
I could look at this and kind of see, wow, this is how you can make a game. This is how programs work. Obviously in a very basic sense, but still.
One of the great things about keying in BASIC programs from a magazine is that they sneakily teach you BASIC as you're doing it. The BASIC language is relatively simple. You have variables, you can do operations on them. There are occasional commands that control input and output, like changing the screen, putting shapes on screen, etc. As you type in a program, you can't help but learn the language.
So someone sent me these recently. This is a fascinating idea for me and something that uses BASIC in a way that I hadn't really seen until recent years. And these are called micro adventures. These are little novellas, and they're written just like a normal novel. But when you get to certain points in here, you're going to get, it's like, oh man, something happened. To see what happens next, you type in a BASIC program, and it's going to, some programs aren't going to work. It's got a little list here of like IBM, Apple, Radio Shack, Commodore, TI, and Atari. But for the most part, the programs work. Like, see, this one has all the check boxes. And yeah, if you have the right machine, you can see what happens next in the book with a little bit of interactivity and graphics and things like that. It's just a fascinating idea.
Clint sent me some pictures from the book so I could print them out and try typing some of these in to see what they do. I decided to use my Radio Shack color computer since it is on the supported list. Actually, it's probably easier to type in from this copy since I don't have to hold the book open while I type. So it appears to just be some kind of program for encrypting or decrypting secret messages. It won't really do me a lot of good unless I actually read the book.
And that just goes to show you how popular BASIC was. I mean, this is number 6, number 7. I don't know how many there were in the series, but obviously it was a thing.
Okay, so another book I want to show you is this old algebra textbook. Now, it took me forever to find one of these to show you, but I thought it was really important that you see this. Most of these books, I think, were destroyed because, unlike colleges, high school students don't actually own these books, and eventually they're returned to the school, who either destroys them or sends them back to the publisher. But for me, every math textbook I had in school, from junior high all the way through graduation of high school, had BASIC in it. We usually had some Apple II computers in all of the classrooms, even if it were just one or two of them. And after you learned how to do the math in that chapter, you could go over to a computer and try using the concept you just learned by typing in this BASIC program. You can see this book was first issued to somebody named Brad Carter in the year 1990. So this was probably one of the last books that contained BASIC code like that. By the early 1980s, nearly every personal computer manufacturer, including Apple, had switched to using Microsoft BASIC. And while today, when we hear the term Microsoft, we tend to think of Windows and Office, but even back then, almost every personal computer displayed the Microsoft logo somewhere in BASIC.
If you crack open an old Apple computer, like we have an old Apple IIgs here, you'll see inside the Apple a chip labeled Microsoft. Dogs and cats sleeping together, mass hysteria. Just because they had the most popular BASIC. There was a fun story with the Commodore 64. How did that work? He licensed Jack Tramiel licensed the BASIC from Microsoft to work on the PET, and he basically didn't change it for all the successive computers. So the original one-time license cost stretched over all the millions of Commodores that he sold.
People make a lot of fun of Microsoft. They did back in the day, they still do. But it is pretty hard to deny them their achievement of Microsoft BASIC. For what they packed into the ROM that was installed in all these personal computers, it's pretty amazing.
Now, you would think that BASIC would be universal by this point. I mean, all computers were running Microsoft BASIC, right? Unfortunately, all of the commands for graphics, sound, and disk drive operation were still proprietary.
But yeah, the difference in dialects is interesting. It's like learning different accents for a language. You can learn Southern American English, and then you've got like Northwestern American English, and then English, and then Scottish English.
But it wasn't just the language that was different from one of these machines to the next. Each machine had its own unique personality. BASIC was more than just a language. It was, in essence, the entire operating system and the user interface. As an example, on the Commodore 64, if you had a game on floppy disk or cassette, you could put the game in your drive, but you still had to type a command in BASIC to load it up. Of course, most games had instructions on the disk telling you exactly what to type. For many Commodore users, the command load *8 was the only BASIC command they actually knew, and they didn't even know what it meant, they just knew that it started the games. But other machines used entirely different methods of starting a program on a disk.
The thing with BASIC is there's no one BASIC. There's different interpretations between all sorts of hardware, and that's something that threw me off at first.
Also, the screen editor itself is very different. For example, in BASIC, the Apple II gives you a little prompt when you type in a command, and for whatever reason, if you mess up, don't go for the backspace key. Instead of correcting your mistake, it'll infuriatingly make it worse. No, you have to use the cursor keys to back up. Commodore BASIC, on the other hand, has a really nice screen editor. The backspace works like you would expect, and if you want, it's easy to cursor back up into your program listing and make changes. Although the cursor keys are weird, there are just two of them. So this one goes up and down, and this one is left and right. You have to use the shift key in combination to change the direction of the cursor. It's weird, but you get used to it after a while. On the Apple, if you want to move around the screen, you have to hit the escape key and then press secret letters to move it around. One of the neat features that all Commodore systems had was its use of quotation marks. So whenever you typed a quotation, such as in a print statement, it would actually use special symbols to record any commands you typed. So for example, I can press home key, type a word, cursor down 3 spaces, cursor right 3 spaces, change the color to something else, and type another word, and then close the quotes. Now when I run the program, it will remember that exact sequence of commands. That was always really helpful. So, Commodore BASIC had a great screen editor and a lot of other really nifty features in BASIC, but it had one Achilles heel, especially with the VIC-20 and the C64, which were the best-selling machines they had, which is they had no graphics and no sound and no disk drive commands built into BASIC. They did have load and save, but that was it.
While machines like the Apple II could just type catalog to get a listing, the Commodore had a bizarre method where you had to load a program called $sign from the disk drive. The disk drive itself actually did all of the work, constructing a small BASIC program and then sent it back to the computer, so now you could list the program and see the contents of the disk. The problem with this was if you were in the middle of working on a BASIC program, you just lost it because now it's overwritten by this directory listing. This was largely solved by additional cartridge such as the EPYX fast load. Besides increasing the disk speed tremendously, it added many commands to BASIC, such as typing a $sign to get a directory without overwriting your program. Also, you could get a menu with all sorts of useful stuff. This cartridge was so popular, every serious Commodore user had one, but that still didn't help with the graphics command situation. According to the manual, if you wanted to do graphics, you would need to type in all kinds of complicated poke and peek statements which directly changed the registers of the graphics chip. It was slow and really difficult to understand what was going on. So if you wanted to draw a sine wave on the screen of an Apple II, no problem. A few lines of BASIC using the built-in graphics commands would easily take care of that for you. But the VIC-20 or C64 was a nightmare. However, you could get cartridges like the Super Expander for the VIC-20, which added a variety of commands. And on the C64, Simon's BASIC was quite popular, which did essentially the same thing.
So speaking of cartridges, the original Atari machines did not have BASIC built into ROM, which was actually very unusual in this time frame.
If you just booted up the computer, it went straight to something called MemoPad. It's basically just a useless text editor that wouldn't even save your work. However, they did give you a cartridge with BASIC on it.
To stick in a BASIC cartridge right here in the left slot. This one was never used for anything. Else, if you turned it on, you'd be in no BASIC mode. So if you were playing a game that was larger, like Ghostbusters or Rescue on Fractalus, it shadowed 8K of memory. So if the BASIC cartridge was in place, you'd lose 8K for your games. So larger machine language games couldn't fit in memory. So you'd actually have to take the BASIC cartridge out to play some games.
Later machines like the 800XL and all of the ones that came after did, of course, have BASIC built into ROM.
And that was cool because it was right there. You could turn on the computer and it was ready to go. You could type in programs without having to do anything else. You don't have to boot into something separate like you do on an IBM PC. And that was really appealing to me.
In fact, not only was it instantly available, you didn't even have to really write a program.
That's right. You could actually type commands right at the prompt. So if you wanted to do a mathematical calculation, just type print and then your math problem, and it would print the result out. You could even do loops and stuff without ever even entering a program.
I mean, it was approachable, right? The thing about BASIC was that it was so approachable. It was very much a logical thing where you could look at it, and once you figured out what things like pokes and stuff were, it made sense. You could just read it, or at least I could. It made a lot of sense to me, and I liked that about it.
Okay, so I've shown a bunch of horribly bland programs that were designed to be generic, to work on just about any computer that runs BASIC. But what could you do if you wanted to write a program for a very specific platform in BASIC? How could you make it better?
Well, Steve Wozniak was one of the first to show what you could do. Not only did he write his own version of BASIC called Integer BASIC, which he specifically designed for making games, but in 1976 he wrote his own game, Little Brick Out. He said it took him 30 minutes to write it. And that's really the power of BASIC right there. You can write stuff very quickly.
The thing about BASIC, the beginner's all-purpose symbolic instruction code, is it wasn't fast, and it's kind of like the best modern day analogy would be Python. Python is a language where every command is interpreted as it comes across it. So instead of compiling it, it's like, oh, if that equals that, then this. It does it all real time. Now, with today's modern computers, they're so fast that you really can't notice that there's a lack of speed.
So BASIC is easy to learn and it's fast to write something, but it did have severe limitations on these 8-bit computers, especially when it came to speed. But I think that's one of the challenges that makes it interesting and keeps me coming back writing stuff in BASIC, because it's interesting to see what I can do within those limitations.
For example, a few years ago I decided to attempt to write Tetris in BASIC on the Commodore 64. It's not a terribly long program, however it did take me an entire day to write it. The first version I wrote only took about an hour, but it was so slow that it was not playable, so I spent the rest of the day figuring out ways to speed it up. In the end, it worked, and so now you can play Tetris in BASIC. There were some other commercial games that were written in BASIC, such as Sword of Fargoal, and another one called Telengard. I wanted to give you a way that you could see the speed difference between BASIC and machine language, something you could see that would really make sense. So I'm going to write a little BASIC program just to fill the screen with all 256 characters, writing directly to screen memory. So you can see it takes a few seconds to do that. Now I'm going to write the same program in machine language, and let's watch. Dang, it's so fast you can't even see it draw it out. However, it was possible to speed up BASIC to some extent. Well, beyond just moving to a faster computer. One option was using a compiler. For example, the Blitz compiler would take your BASIC program and convert it. It's not exactly converting it to machine language, but it converts it to a sort of in-between stage. And you can see it's a good bit faster than the original BASIC. In fact, after compiling my Tetris game, it's so fast I can barely play it now. But don't be fooled, these compiled BASIC programs, they're about double the speed of a traditional BASIC program, but they're still a fraction of the speed of a machine language program. But on the bright side, you do get the convenience of programming in BASIC, an easy language, and it gives you a little extra speed.
I like BASIC. It's nothing overwhelmingly powerfully fast or anything like that. In fact, there's so many limitations with it that that's honestly why I find it so fascinating even to go back to now. Anytime that I get a new old computer, I try something in BASIC first.
What do I miss about BASIC? I mean, that's like having a Ferrari and then someone asking you what you miss about your Ford Escort, besides the lower payments. Well, here's one thing. It was really easy to make something quick and fast.
I miss just being able to turn on a computer and just have BASIC right there where you could just start typing something in. I miss that direct connection that BASIC gave you to the computer it was designed to work with.
And I think that's why nowadays I don't really care that much about Linux, is because back in the 80s, everything had to be done with typing and scrolling screens of text. And I guess I wasn't really sad to see it go because I'm like, I did my time with that. But I think younger people, they kind of miss the romanticism about how these computers worked.
All right, so I think we have reached the end of this unusually long episode, but I have a few things I want to say in closing. First of all, a big thank you to Clint from LGR, as well as Jim Leonard and Ben Heck. This episode was originally going to be a lot longer, and I ended up cutting a lot of stuff out, or at least shortening some things down. And one of the reasons was I thought, instead of making an hour-long episode about BASIC, there were some of these things that I thought really kind of deserved their own episode. Just as an example, I'm going to do an entire episode on the VIC-20 Super Expander. I know it seems kind of mundane, but there's a lot of interesting things that this cartridge does. So I'm going to be doing an episode on that, as well as many of the other topics that were glanced over in this episode. So don't feel like you're going to be missing out. I'll eventually cover those things. In the meantime, keep watching. I've got a lot more stuff coming, and I am doing YouTube full time as of February of this year, so hopefully I'm getting more content out there. Well, see you next time.